Okay, so today we're going to start our study of polynomials, but before we jump into polynomials, we're going to go back and review the most basic polynomial that we have played with for a long time, a quadratic. So a quadratic we know lots about, but let's talk about polynomials first. So a polynomial function, f, right here, which we call like f of x, its name, of degree n, the highest power is the degree, where n is a non-negative integer given in this form. And we have these little subscripts, a sub n minus 1, so on, is known as a polynomial. So this right here is a polynomial. It's known as the constant function. Its degree is 0 because right here we would have x to the 0th. Anything to the 0th power is 1, which just makes 2. Its leading coefficient is 2. It is the number in front of the x. The next one is a linear function. Its degree is 1 because the power right here, my x, is 1. Its leading coefficient, the number with the degree, is 5. Quadratic, my biggest power here is a 2. My degree is a 2. So since my degree is a 2, it's called a quadratic. The leading coefficient is the number in front of the x with the degree, so that's a 4. Highest power here is a 3. When it has highest power of 3, it's known as a cubic. And the number right here in the front is the 2. Now, please don't think it's the number in the front. It's the number that has the x with the highest power, the number that has the x with the degree. So, for example, if I looked here, if this were my highest power, then this would be my leading coefficient. However, that's not the case in this problem. My highest power here is a 4. When it's a 4th power, it's called a quartic. Its leading number right here is a 1, so my leading coefficient is a 1. So that is classifying polynomials. Now on to looking at parabolas. So we have looked at parabolas before. This right here is a quadratic function, ax squared plus bx plus c, and a cannot equal 0 because we wouldn't have an x squared term. You have also, and in the following pages we'll see this, we've also seen this in a couple other ways. F of x equals a x minus h plus k, and that's squared. It's called vertex form. This one over here is called standard form. But both are parabolas and quadratics. Parabola is the shape, quadratic is the name of the family. So at the most basic simple level, a quadratic function is just f of x equals x squared. This is known as the parent function, because there's no transformations that have happened yet, no stretching, no moving, nothing of that nature. Here's its table, and this was formed by plugging these x's in right here. And then when you plug those in, out come those y values, those inputs and outputs. And this is its graph, its domain, and the domain of almost all parabolas is negative infinity to infinity because it moves sideways to the left and sideways to the right forever. The range, however, is going to change based on my transformations. In this case, this right here, this magic point, hope you remember that this is called the vertex. And this parabola opens up, it's going up. So my range is one of two things. If I open up, then it's from the y part of the vertex to infinity. Put a y part there. If I open down, then it would be, oops, that's supposed to be a parenthesis. It would be from negative infinity to the y part of the vertex, the bracket. So it says that the graph of parabola, this is a graph of parabola, every quadratic function has real coefficients, defined over the real numbers. The domain, as I said earlier, even though it says for this function, but the domain is almost always negative infinity to infinity, and then this range is going to change depending right here on what occurs. And then don't forget about our special words we learned in chapter 2. This function does decrease on the interval from negative infinity to 0, so I decrease on this side. And I'm going to increase and get bigger on the other side. This graph also has something pretty cool called the axis of symmetry. It's like a mirror. So the axis of symmetry is the line that goes straight through the vertex and cuts the parabola in half. So this red line I'm drawing is known as the axis of symmetry, which sometimes we abbreviate as AOS. If I put a mirror on that red line, I will get the other half of the parabola. It's symmetrical about that red line. So for example, this dot right here is over 1 and up 1. So there's another dot on the other side that goes over 1 and up 1. This next dot is over 2 and up 4. So there's a dot on the other side that does the exact same thing, over 2 and up 4. They're symmetrical. And this is what I was referring to earlier, opening up and opening down. If the parabola opens down, then this vertex right here is called a maximum, because it's the highest point. But if this parabola opens up, then this vertex right here becomes a minimum, because it is the lowest point. Okay, and then here's the vertex form we talked about on the previous page. So there are different ways to graph. You can graph old school, like just make a table, which is something that will never fail you. We can put it into vertex form, because then we have a vertex. And we can use some key things. So key things. This A up front tells me all kinds of cool stuff. Does it open up? Does it open down? Is it stretched? Is it shrunken? Etc. This H is my side-to-side movement, so it tells me, did I move right or did I move left? And this K at the end tells me, did I move up or did I move down? It's my Y movement. So remember that this right here is called vertex form. But this version down here, sorry, my minuses and pluses didn't print minus. This version down here is called standard form. So if I'm in standard form and I want to get to vertex form to use all these cool things, the H and the K, I'm going to have to remember that I'm going to have to complete the square. Something we did a lot in chapter 2, and we're going to keep using. So let's go ahead and look at doing that. So this first problem says that it wants me to graph and give the domain and range. So you absolutely can make a table and start with that. I am going to start by taking my standard form and going to vertex form. So let me do that. So I have y, f of x is the same thing as writing y. So I have y, and then remember you have to move this over. So y plus 2 plus that magic blank line equals x squared minus 4x plus the blank line. We did check that this leading coefficient in front of the x squared is a 1, so I don't have to pull anything out. This line right here is b over 2 squared, and this right here is my b value. So negative 2 divided by 2 is going to make a negative 2, and then I'm going to square it, making it a 4. And if you add a 4 on one side, you have to keep things even and equal, and put the 4 on the other side as well. And so now I'm going to get y plus 6 equals, and then I have x squared, x squared minus 4x plus 4. So y plus 6, this 4 that we added in here makes this side the perfect square that it factors into x minus 2 squared, and then you have to subtract the 6 over. So y, actually we'll go back to calling it f of x. Y is the same thing as f of x, so f of x, I moved this 6 back over to this side, equals x minus 2 squared minus 6. That means my vertex is right here. Now remember, it was supposed to say minus h and plus k. So my vertex, the minus matches the minus, so my vertex here is going to be 2 comma, it was supposed to be a plus k on the outside, but it's not, it's a minus. The signs don't match here, so this is a negative 6. So my vertex is going to be 2, -6. So 2, -6 right there. And now we have some options. We can make a table. We can factor and do some other stuff. I'm going to go with the table route. I know where the vertex is. I also know that vertex is like an axis of symmetry. So I'm going to draw a yellow highlighted line. Oh, it's very thick. Hang on. Let me try drawing a yellow line this way. So this blue, the vertex, that blue dot, is on this axis of symmetry that I've drawn in yellow, which is like my mirror. So if I draw a dot on one side of the mirror, then it's going to show up on the other side of the mirror. So if I make my little table, X and Y, and we want to plug something in. I don't know. 0 is easy to plug in. Let's plug in 0. You can plug in 0 to your original equation up here, or into this version right here. I'm going to go back to the original. So I get 0 squared is 0, minus 4 times 0, so minus 0, minus 2. That's going to make a -2. So at 0, I'm at -2. This dot right here is over from my vertex 1, 2, and up 1, 2, 3, 4. So I go over 1, 2, and up 1, 2, 3, 4. There's my mirror dot. Let's plug in 6 and see what happens. If I plug in 6, 6 squared is 36, minus 4 times 6 is 24, minus 2. If I do the 24 and the 2 together, I get 26, so that's going to be a 10. So that means at 6, I'm all the way up at 10, and this is 1, 2, 3, 4 dots away, so I go over 1, 2, 3, 4 dots right here, and then I can draw my parabola. There's my parabola. This says give my domain and range. My domain is negative infinity to infinity. This parabola moves side to side forever. My range, this parabola opens up. So you go from your vertex, that bottom dot, and all the way up. So my vertex is going to go that bottom dot right here at -6. So I go from -6 and up forever. So there's my domain and range. Okay, on the next example, they want me to graph y equals -1/2 x squared and compare it to the other two graphs. So let me start with the other two. This is my parent function, what we had on the other page. So it hasn't been moved anywhere. Its vertex is at 0, 0. If you plug in 1 and square it, you get a 1. And if you get a dot on one side, you get a dot on the other. If you plug in 2 and square it, you get 4. Dot on one side, dot on the other. 3 squared is 9. So this is my parent function. Let's graph this one and see what happens with the 1/2. So that 1/2 is not changing. It's a stretchy thing. So that dot's still going to be there. And let's just plug in dots. Plug in points. If I plug in 1, 1 squared is 1 times 1/2 is 1/2. Oh, these y values are getting half as much. So when I plug in 1, I'm at 1/2. If I plug in 2, 2 squared is 4. 4 times 1/2 is 2. So at 2, I'm at 2. 2, I'm at 2. I'm not going to plug in 3 because 3 squared is 9. 9 times 1/2 is another fraction. Let's try 4. 4 squared is 16. Half of 16 is 8. So at 4, I'm at 8. 4, 8. So we can see that 1/2 didn't translate me side to side or up and down, but it did make my parabola become wider. So taking those two things into account, I'm going to be wider. I have the 1/2, but that negative is going to make me graph upside down and reflect over the x-axis. This is making the y's negative, and when you make the y's negative, you have to cross the x-axis. So if you plug in 0, I'm just going to graph this one and make a t-chart again. X and y. If I plug in 0, 0 squared is 0, 0 times anything is 0. I stay there. If I plug in 1, 1 squared is 1 times the -1/2 is a -1/2. So 1 -1/2, and I have a dot on the other side. If I plug in 2, 2 squared is 4. 4 times negative half is negative 2. So 2, negative 2. Not going to do 3 because of that half. Let's do 4. 4 squared is 16. Half of 16 is 8. And it's a negative. So 4, negative 8. So this red one looks just like my green one, except the negative, it's been reflected over the x-axis. So that is also my comparison. I don't know what happened when I made this. All the signs are gone, so let me write the signs in really quick. Equals, positive 1/2, minus, plus. Okay, so we're going to graph this one. Luckily for us, this one's already in vertex form. Remember, it's supposed to say a x minus h squared plus k. So the minus and the minus match up. So my h value, my vertex is hk. My h value is 4. The plus and plus signs match up. So my k value is 3. So my vertex is going to be 4, 3. This also becomes my axis of symmetry. So I put a dot on one side, put a dot on the other. Let's graph some points. X, Y. Let's plug in 6. Why not? 6, so I have 1/2, and then 6 minus 4 is 2. 2 squared is 4, plus 3. Half of 4 is 2. 2 plus 3 is 5. So at 6, I'm at 5. That's over 2 and up 2. Oh, let's see, what else can I plug in? I can try 8. 8 might be too big. We'll try. If I plug in 8, I get 1/2. 8 minus 4 is 4 squared, and then plus 3. So 4 squared is 16. Half of 16 is 8. 8 plus 3 is 11. So at 11, this side I just drew is over 1, 2, 3, 4 from that axis of symmetry. And I go over the other way, 1, 2, 3, 4, and then go up to 11. So there is my parabola. Let me write my signs in before we graph the next one. Should be equals, minus, and a plus. Okay, so I want to graph this one, but it also wants me to find the largest open intervals for which the function is increasing and decreasing. And I'll be very honest, I don't really love this verbiage, but it's the way your textbook phrases it. Largest open interval. So open interval means that you have parentheses on both sides. It's not a closed interval where you have a hard bracket. So open intervals, anytime it says open interval, parentheses. Largest just means don't restrict it. Don't say from here to here if it keeps going on forever. And I'll elaborate on that more in a second. So let's graph this one first. And to graph, I'm going to convert it. So I'm going to call it y for a second. Y equals x squared minus 6x plus 7. I'm going to complete the square so I can find the vertex. I'm going to minus the 7 over. So y minus 7 plus blank equals x squared minus 6x plus blank. That blank is b over 2 squared on both sides, as long as there's no leading coefficient. So let me erase that. I'll look at there. So b is -6. -6 divided by 2 is -3. -3 squared is 9. If I add 9 to one side, I got to add 9 to the other. So this side becomes y plus 2 equals, this side factors into x minus 3 squared. So f of x equals x minus 3 squared minus 2. Remember, it's supposed to say a, x minus h squared plus k. So my vertex is going to be 3 comma -2. So 3, -2, there's my vertex. And now let's make a table and plug some points in around that vertex. Let's plug in 0. 0 is super easy because you get 0 squared minus 0 plus 7. So 0, 7. And that was over, drawing my axis of symmetry, that was over 3 dots. So we can go over 1, 2, 3 dots the other way. There's another point. Let's plug in 1. 1 squared is 1 minus 6 plus 7, negative 5 plus 7 is 2. So 1, 2. So here's my parabola. Now to answer this, find the largest open intervals for increasing and decreasing. Open intervals, parentheses. On this side, I am decreasing till I get to my vertex. So decreasing. To make it the largest, we're going to start from negative infinity up until that y value, or sorry, that x value gets to 3. That side's decreasing. This side is increasing. So from 3 to infinity. Let's try another one. This one should say equals negative 3x squared minus 2x plus 1. Same directions, find the largest open intervals over which the function is increasing and decreasing, and graph it. Okay, let's see. Let's do the graphing first. So I'm going to move the 1 over. Y minus 1 plus blank equals, this a value is a negative 3. So you have to remember, pull out the negative 3. X squared, you pull the negative out, so it makes it a plus. 2 over 3 plus blank. And if you want to check, you can multiply this 3 back in, and the 3's will cancel out. You get that 2 that you had. This is b over 2 squared. So b, oops, I forgot the x, sorry. X. So b is 2/3. So 2/3 divided by 2 is the same thing as 2/3 times 1/2. And those 2's are going to cancel out. So you get 1/3. And then you have to square it. And so when you square that, you get 1/9. Now be very careful. You didn't add 1/9. You really added negative 3 times 1/9. So this blank over here is negative 3 times 1/9, which makes negative 3/9, which is negative 1/3. So on this side, I have negative 1/3. So now when I combine stuff, I get negative 1 minus 1/3 is negative 1 1/3, or negative 4/3, equals negative 3. And then this side magically factors x plus 1/3. So then I'm going to put everything over. F of x equals negative 3, squared. X plus 1/3 squared plus 4/3. So my vertex is going to be negative 1/3, because it's supposed to be a minus in there, comma 4/3. So negative 1/3, 4/3, like that. Now from here we could absolutely make a table. And you are more than welcome to, but I'm going to show you a little bit of a different trick just because I know that making a table is going to be a little bit messy. One thing that we could do is right here, we know the y-intercept because if we plug in 0 for the x's, the y-intercept comes out. And so we know we have a y-intercept right here of 1, which means we know we have another dot over here. That doesn't help me too much, but what I can do is the following. I can actually go back and factor this. So let me take my parabola. Ooh, sorry. Let me take my parabola. Negative 3x squared minus 2x plus 1 equals 0. I'm going to divide everything by a negative. 3x squared plus 2x minus 1. I'm going to factor this, equals 0. So 3 times negative 1 is negative 3. 2 factors of negative 3 to add up and make positive 2 are going to be 3 and minus 1. So I'm going to get 3x squared plus 3x minus 1x minus 1, factor by grouping. The first two have a 3x in common, x plus 1. The other two have a minus 1 in common, x plus 1 equals 0. And they both have an x plus 1, right here and right here, and left with 3x minus 1. If you take each one of these factors and you set it equal to 0, you are finding the x-intercepts, the roots. So I'm going to do x plus 1 equals 0, 3x minus 1 equals 0, x is going to equal negative 1, and x is going to equal 1/3. So there's 2 more points I have. So you can always try factoring, and that'll help you find the x-intercept. So we said that x equals negative, negative 1 and positive 1/3. So that means this dot I drew is not quite in the right place. But I know my math is right. So we said negative 1 and 1/3. And I can venture that this parabola looks something like this. If you wanted to plug another dot in, you absolutely could. Absolutely could. So intervals of increasing and decreasing. So on this side, this time I'm increasing. And remember, this vertex point was negative 1/3, comma 4/3. So for increasing, I'm going to go from negative infinity to negative 1/3. This side is decreasing. And that's going to be from negative 1/3 to infinity. Okay, so on the next page, they go through and they derive a formula that I'm pretty sure you learned in Algebra 2. You learned in Algebra 2 to find the axis of symmetry. You could do x equals negative b over 2a. And they go through and derive that. And so what they prove is that this h, the x part of the vertex, is equal to negative b over 2a. So h, x part of vertex, is negative b over 2a, which is what we have right up here. You don't have to memorize that. You do need to know that x equals negative b over 2a, but you don't need to memorize all the color typing up above. So here's some things we should definitely know that will be helpful. You should know that h equals negative b over 2a, which sometimes we call x. We can find the rest of the vertex by plugging in. So you take this and plug it into f, and you'll get the y part of the vertex. You should know that hk is the vertex, and that x equals h is the vertical line or the axis of symmetry. If a is greater than 0, it opens up. If a is less than 0, it opens down. If the absolute value of a is less than 1, it is wider. And if the absolute value of a is greater than 1, it's narrower. Let me draw. Narrower would be like it's super skinny versus wider. It would be like this. We always can find the y-intercept, and I think this is much more useful. Y-intercept for anything, not just a parabola or a quadratic, anything. Let x equal 0. Always, always, always. And then the x-intercepts are found by doing one of the following. So before I discuss all that, let me address this. You can find out how many x-intercepts you have by finding what's called the discriminant. And the discriminant is just the piece under the quadratic formula. B squared minus 4ac. So there's 3 cases. B squared minus 4ac is greater than 0. 2 x-intercepts. They come out of this quadratic formula that we have right here. B squared minus 4ac equals 0. You're going to have 1 x-intercept, which is right here. It's the axis of symmetry value. And if b squared minus 4ac is less than 0, you're going to have no x-intercepts. Oops, I forgot the letter x. And if we have no x-intercepts, that means the quadratic formula would have had an I, an imaginary thing in it. Okay, so let's use some of that information to solve the next page. So equals 2x squared plus 4x plus 5. So if I want to find the axis of symmetry and the vertex, to do the axis of symmetry, remember I can do x or h equals negative b over 2a. So my b is 4, so negative 4 over 2 times a is 2, a x squared plus bx plus c. So you're going to get negative 4 over 4 equals negative 1. So the axis of symmetry is x equals negative 1. Now to find the vertex, you're going to take that and plug it in. So you're going to do f of negative 1. So that's 2 times negative 1 squared plus 4 times negative 1 plus 5. So I get 2 minus 4 plus 5. 2 minus 4 is negative 2 plus 5 gets 3. So my vertex is going to be the x value I plugged in was negative 1 and I got out 3. This is my vertex. So parabolas are often used for projectile motion, balls being thrown or launched, anything that is shot or fired in a distance, and it makes a parabola or projectile motion. So this is the formula right here we commonly use. It's negative 16t squared plus, this is red, v naught times t plus s naught. The initial velocity is v naught plus s naught, which is the initial height, and t is time. This negative 16, if you are taking physics, it's actually negative 1/2 g, where g is the force of gravity. Gravity in feet is 32 feet per second times the negative 1/2, which is where the negative 16 comes from. So the next problem says we're going to use that model from the previous page, the negative 16t squared plus v naught t plus s naught, to model this given situation, which says that a ball is projected directly upward from an initial height. So this is my s naught with an initial velocity, v naught, of 80 feet per second. So give the function that describes the height of the ball in terms of t. So s of t equals my negative 16 t squared plus v naught was 80 times t plus s is 100. After how many seconds does the ball reach a maximum height? This is a key word. A maximum is the same thing as finding a vertex. And to find a vertex, we have a formula that says x equals negative b over 2a. Since we don't have a variable x, we have a variable called t. We can replace the x with a t. So if I want to find this, t equals negative b, or the opposite of b, so negative 80, over 2 times negative 16. A negative divided by a negative is a positive. You're going to have 80 divided by 32. 80 divided by 32 is 2.5 seconds. So that's your first answer. After how many seconds does the ball reach maximum? After 2.5 seconds. The next part then says, what is the maximum height? So I want to find the maximum height. I need to plug this value in. So I need to do s of 2.5 equals negative 16 times my 2.5 squared plus 80 times 2.5 plus my 100. When you crunch that out, it becomes 200 feet. So that's my maximum height. The next question says, for what interval of time is the height of the ball greater than 160 feet? So let's take our model. negative 16t squared plus 80t plus 100. And I want this to be greater than, I want the height to be greater than 160. So I'm going to subtract the 160 over and get negative 16t squared plus 80t. Subtract it over, you get negative 60, greater than 100, or greater than 0 now because I moved it over. I'm going to divide everything by a negative 4 just to reduce everything. 4t squared minus 20t plus 15 is now less than 0 because when you divide by a negative, that flips the inequality sign. And then I'm going to take this and I'm going to do the quadratic formula because I need to find those t values. So quadratic formula is going to be the variable's t. So instead of x, we're going to write t. So t equals the opposite of b. So 20 plus or minus square root of b squared. So negative, let me erase that. Negative 20 squared minus 4 times a, which is 4, times c, which is 15, all over 2 times a, which is going to be 2 times 4, which is 8. Okay, so now I'm going to take this up here and I'm going to simplify it. T is going to equal 20 plus or minus 4 times 4 times 15. 4 times 4 is 16. 16 times 15 is 240. 20 squared is 400. So we're going to get the square root of 400 minus 240 is 160. All over 8. 160 is 16 times 10, and the square root of 16 is 4, so this is 4 root 10. T equals 20 plus or minus 4 root 10 all over 8. And then this and this and this can all be reduced by a 4. So T is going to equal 5 plus minus root 10 all over 2. So if you type those two numbers in the calculator, you get about, T is about 0.92 and 4.08. So if we go back here to this parabola with the yellow dots, and think about this parabola has 2 real x values where it touches the x-axis, and this leading coefficient a is 4. So its graph looks something like this. 2 real x-intercepts. It opens up because this 4 right here is positive. So here's what we know. This first dot right here is like the 0.92. 4 is bigger than that, so this is my 4 dot. And it wants to know where is it greater than 160. Well, I'm greater than 160 from negative infinity until that 0.92 when I touch and cross the x-axis. And then from in between, from right here, the 0.92, until I get to 4.08, I am underneath the x-axis. And then I cross the x-axis at 4.08, and I am greater than that until I get to infinity. So here are my 2 answers. And then the last question says, after how many seconds will the ball hit the ground? Well, the ground's height is 0. So we're going to let S of t be 0. So 0 equals negative 16 t squared plus 80 t plus 100. All of those are divisible by 4. So 0, actually do a negative 4. 0 equals 0 divided by anything is 0. Negative 16 divided by negative 4 is a positive 4t squared. Minus 80 divided by a negative 4 is going to be 20t. And then 100 divided by negative 4 is going to make a minus 25. We could have done the quadratic formula right here, but I've just reduced everything. I'm going to use the quadratic formula right here, just because the numbers are a little bit smaller. So we're going to get t equals the opposite of b, so 20 plus or minus the square root of negative 20 squared minus 4 times negative 25 all over 2a, so 2 times 4. And we really can just use a calculator for this. So using a calculator, if I do the plus part of the formula right here, the plus, I get that t is about 6.04. And then if you do it again with the minus part of the formula, you get that t is about negative 1.04. These are both in seconds. So the question is, when does the ball hit the ground? This is not the answer because we can't have negative time. So this is saying that the ball, somewhere in a negative time over here, then the ball was launched up, and then it went up, 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 and then it comes back down over here and hits the ground. And this is the 6.04 seconds. So after approximately 6.04 seconds, the ball will hit the ground.